All right, 9.7, today we're going to look at applications, and specifically with exponentials and logarithms, okay? And so applications means word problems. So today's going to look a little bit different. I'm going to be kind of bouncing back from the computer to the board here. I'll bring up on the computer the word problem, so I don't have to write all that out. You can take screenshots of those. Or if you're in my class, go into Canvas, just bring up the document and you can follow along. And then I'll work through those. And again, you can follow along there in those Canvas documents to see what's happening and not have to write everything down. But I want to walk through it by hand so you can see those pieces and understand what's happening there. Okay. But before we get into the word problems themselves, we do have one definition that we need to define here. Okay, so definition. And so for our purposes here today, we're going to look at P of t equals P sub 0 times e to the kt power. Okay, so that's going to be our exponential formula for the day. Now we're going to be able to manipulate, work with this piece. This is what we call a growth and decay problem based on what our powers are. For them. All right. Now, there's a lot of things going on there that we need to know about. Okay. So let's define the little individual pieces. Our first piece, P of t, this is the amount after time. Okay. So, for instance, if you go to the bank and put money into the bank and you leave it there for a long time and you acquire interest on it, after all of that time, this is the amount in there, assuming you don't touch it, don't add anything to it, do anything else with it. You just simply leave it alone and let it grow on its own. That's going to be the amount after time. Okay. P sub 0, that's a little subscript there for that. So it's just P sub 0. This is the initial amount. Okay, how much you put in originally. So again, going back to that bank thing, how much did I go and deposit the first time that I went in before interest started accruing? Okay. E is the letter E. We've already talked about that before. K is our rate. So they always talk about percents. We always change it to a decimal. Okay, for those, but it's always going to be our rate. And then T is the time in years. Okay, so time in years for those. And so that's what we're going to be putting into those things based on what they tell us. And then we have to solve for some other things. Okay, and so a lot of times we're going to be solving for the time and working with that. So we have to be aware of those pieces. Okay. All right, so let's get into our problems here and go and see what's going to happen. So I'm going to share my screen and I'm going to be back and forth with this. Okay. You're going to see I jump to the computer and then I jump back to the board. All right. So yeah, again, you may want to take screenshots, or if you're in my course, go ahead and go to that Canvas document, bring it up so you can follow along. All right. All right. So our first problem here, it talks about some city. It's 2012. The city had a population of 6.63 million. The exponential growth rate was 3.16 that year. Okay. And then it wants to know, what is the growth function? What will the population be in 2018? And then the population, when will the population be 9 million? And then find the doubling time. Okay. So we're going to look at each one of those pieces and break it down and see what else is happening for them. Okay. All right. So I'm going to go back to the board here. I'm going to stop share. Let me erase this piece so that we have plenty of room to work. We've got a lot of parts. All right. So it said it's 2012. That's just kind of our starting year. That gives us a date to start with for these pieces. Okay. And then it says our population was 6.63. So that lets me know that P sub 0 is going to be 6.63 million. And now I'm going to write million, but we're going to know all of our answers are in millions. So I'm not going to put million in my problem. I'm just going to put 6.63 for those, okay? It also says that the growth rate was 3.16%. K is 3.16%, which is 0.0316. We never leave it with this percentage on there, okay? We got to change it to that decimal in order to work with those pieces, okay? All right, so for part A here, to write the equation, it already has P of T on there. So we know that that's the case. Well, that's going to equal P sub 0, 6.63, times E to the K, 0.0316 T. And that is going to be our function, okay? Now, make sure all of this is in your power. This is a power, even the T. Those things are being multiplied in the power. So we got to be careful with that, okay? All right, part B. It wants to know when is the population of the city, or what is the population in 2018 based on this model, okay? So what we do there is we need to find how many years we had there. So first, T is going to equal 2018 minus 2012, because 2012 was our initial year. That's when we started, was in 2012. And so we get 6. Okay, so T equals 6. Well, now we have all of that information. So here, P of 6 is going to equal 6.63 E. And I'm going to put this in parentheses, 0.0316 times 6. So that when you plug that in, this is all calculator work at this point for this problem, okay? So you would plug that into your calculator here, do this in parentheses, so it all is part of the power for that one. And you would see that you get approximately 8.0 when you round that, okay? Because it's going to say round out to 1 decimal place. So that's what we're looking for on that problem, okay? All right, part C. It says the population of the city will be 9 million in how many years? Also, how many years it takes to get to 9 million. So what that means is we know now P of T equals 9. All right, that's what we're looking at. That's the end. It's 9 for those. So we're looking for our T value. So this implies that we have 9 equals 6.63 E to 0.0316 T. Okay, we're looking for T because we're looking for time in years, all right? Okay, now we get into a little bit more work here. So let's look at the process. Now, the process on this problem we're going to use for the rest of the day. Okay, a lot of our other problems are going to use this exact same process. So let's walk through it pretty slowly here, okay? So the first thing when we're trying to work through these, and we have a letter in the power that we need to get by itself, the first thing we need to do is we need to get E by itself. So I'm going to divide both sides by 6.63. So I get 9 divided by 6.63 equals E to the 0.0316 T. Okay. All right. And we do want to leave that. Do not do any calculator work at this point. We're going to wait till the end of the problem, because if we do it too early, we're going to get a rounding error and your problem's going to come out incorrect. Okay. So we want to make sure we wait till the very end to do all of our calculator work at once. All right. All right, now to get this power out of this, we need to take the log on both sides, all right? Or we can just simply rewrite this piece for them, okay? So we can do the rewriting here. And so that means that we're going to have log base E, which is ln, of this thing 9 over 6.63 equals 0.0316 t. Okay, for those. So a couple of different ways you can do it. You'll see in my notes that I did ln on both sides. Well, if I do ln here and ln here, the ln and the e cancel out and leave it here. Or we can simply just rewrite the logarithm as ln, because we're doing our conversion. E goes to the ln, and then we switch positions. So those two switch positions like we did when we converted. So we have both of those options there for that, okay? Well, finally, we need to divide this number off the t, and so we're going to get ln of 9 over 6.63. Probably want to put this in parentheses, divided by 0.0316 equals t. Okay? And you do want that in parentheses when you go to plug in the calculator, but t is by itself now. Okay, so since t is by itself, we can put all of that in the calculator just as you see it there. And so once you do that, you should see that it is 9.7 equals t. Okay, so it takes 9.7 years to get to 9 million people for that one. Right? So we're going to use that process over and over again. Okay. All right. Part D talks about doubling time. Okay. Doubling time for that. So we're going to use a little trick to do that. So if we're going to do doubling time, I'll do it over here to the side. We know that the end amount has to be double whatever the initial amount is. And so instead of multiplying 6.63 and doubling it, what's going to happen after we reduce it, anytime you do your doubling time, you just do, so part D here, 2 equals e to whatever the original power was. Okay? Because no matter what this initial amount is, when I divide, I will get 2 every single time for those. So we're just going to use that little shortcut that says doubling time is this piece. Okay? So now we can rewrite this. We're going to get ln of 2 equals 0.0316 t. And so then we divide. So ln of 2 over 0.0316 equals t. And that tells me, I'll put this in the calculator. Again, this is going to be in parentheses here. You're going to get 21.9 years for it to double. Okay, so for our 6.63 to double, it would take us 21 years for that. Okay. But you see the process each time. I'm writing my equation. I'm converting it to a logarithm, specifically natural log because of the e, and then working down to find out my time there for those. Okay. All right. So let me erase a little bit here. And then let's move on to the next problem. So let me share it. So we'll go down here. Now this one is worked out. Below it there, you'll see all of them are actually worked out in my Canvas page for those of you in my actual class. So you're welcome to, again, go and look at those pieces, print that out if you'd like. So those that are not in my class, you'll see it there, but I'm going to go ahead and work this out on the board so that you can do those pieces as well. Okay. All right. So it says country A has a growth rate of 4.1%. The population is currently 4.607 million people. Okay. The land area of country A is 30 billion square yards. Assuming this growth rate is exponential, how long after will there be one person for every square yard of land? Okay, for that. So we know our ending amount, we know our starting amount. We're looking for time on those pieces. So let's look at those. Right. Now our starting amount is what we have right now. And so that is 4. I'm going to put commas just so that I can see everything, knowing that we don't put commas in the calculator, things like that. But this is a really, really big number. So we want to make sure that we get it right. And then E to the, our percent is 4.1. So that's 0.041 times T. And we want to know when is it going to hit the area, which is 30 billion. Okay, it's a really big number. Now, even though they're really big numbers, the process is exactly the same as what we did a moment ago. Okay, so don't freak out about that. We just got to put them all in there. The calculator can handle those things. Okay, so don't worry so much about that. Okay, all right, so we're going to do the same process that we did in these other problems. So the first thing is we need to divide. So we have 30 billion divided by 4,607,000 equals E 0.041 T. Now I will make my problem a little bit simpler. Anytime that we have division and there are zeros at the end, I'm going to mark out the zeros that match up there. So I was able to get rid of 3 zeros just by doing that simple reduction. Essentially divided everything by 1,000 on those. Okay, and so that's going to make my life easier. So now I can do my ln on both sides, just like I did over there. So ln of all of this. So now it's just 30 million over 4,607 equals 0.041 T. So now we divide by that 0.041. So ln 30 million divided by 4,607, all divided by 0.041 equals T. Okay. Well, we put all this in the calculator now, parentheses around the appropriate places, and we should see that we get approximately 214 years to get to that time frame. Okay. And so again, it's following the same process that we did a moment ago when we were looking at these problems. All 3 of the things that you see on the board are the exact same process. So you've got to have that process down. Okay. All right, let's go to our next problem. Right, so here it's looking at this table of values. And it's wanting to know some information from that table of values. Okay, so while you're kind of looking over that, I'm going to be erasing the board. So we've got quite a few things we've got to answer here, so I'm going to need the whole board. All right, so it says use the data for 1960 and 2012. So I'm going to write those down. It says 1960 in 1960 we have 66.5, and then 2012 is the other one, right? 44.1. So I just want that information there so that I can see it, because I want to be able to work with those pieces, right? 44.1. Okay. All right, so let's go through and find everything that they want here for this problem. Okay. All right, so first it says use the data from 1960 and 2012 to find the value of K. So we're looking for the rate so we can create our equation and then find time and all of those wonderful things that we need. Okay. All right, so let's first find our time. So time here is the difference of those 2 things, 2012 minus 1960. So that means that time is going to be 52. Okay, so we're going to have that we're going to work with. Okay. So that implies that we have our equation. Now, 1960 was the first year. So that's going to be the 66.5. And then we're going to have e to the k times 52. And then our ending time is 44.1. Okay. All right, so now we need to divide, move things around, just like we've done in all of our other problems, because even though it's a k, it's in the same position as t. So our process hasn't changed from what we did earlier. Okay, so we divide 44.1 over 66.5 equals e to the, I'm going to put 52k there. So now we take our ln, 44.1 over 66.5 equals 52k. And then we divide, so ln 44.1 over 66.5, put that in parentheses, divide by 2, 52 equals k, which equals, let's see. Now, if we put that in the calculator, we're going to get negative 0.0079. Okay. Now, I do want to show you something real quick. I'm going to go back to the screen. So I'm going to go back to my computer document here on those. So pay attention to those little details. K here, then notice they didn't put a negative, even though I came up with a negative over here on my problems, they didn't write k equals a negative. Because the problem, k is actually always going to be an absolute value when we're talking about the number. We don't ever say that this is going to be a negative 7%. We'll say it decreases or it increases. So the fact that all of our numbers are going down when we look at the table lets me know it's negative, okay, for those. So k, when you go to plug it in on part A for k, no matter what you get down here, you're going to put the positive, the absolute value, okay? It's always positive. But you'll notice in the second part here, when we're looking at the equation for that piece, so I'm going to annotate just real quick. They put it back in. I'm trying to draw with a mouse, so that's why my circle is really horrible there. Sorry about that. They put the negative back in for those pieces. So that doesn't change the overall problem. It's still negative for that, okay? So we have those pieces. All right, so here's our k value. Again, let me put that in blue, what you're actually going to put in. So you do the absolute value for that. That gives us the equation. And they used m of t. It doesn't matter. P of t, m of t is 66.5 e to the negative 0.079 t. Okay, so that's going to be our equation that we want to work with for the rest of the problem, right? All right, part B. So I'm going to kind of just put a little mark there. Part B. It says in 2015, what percent is going to be there, and then 2018. So a two-part problem. Okay, so the first one is 2015. So we need to find our time is going to be 2015 minus 1960, because that's back to our original. Okay, for those. And so that means t is going to be, 55? And so then we just plug that in. So that means that m of 55 is going to be 66.5 e. And again, I want to put that back in parentheses here so that we get our final answer there, which is going to be 43.1. Okay, so that's just going to go right into the calculator for that piece. Okay, but we also have to do the 2018 minus 1960. So t is going to be, what is that one, 58? Okay. So now I plug 58 in. So M of 58 equals 66.5 e to the negative 0.0079 times 58, which is going to be, what did I come up with there? 42.1 on that one. Okay. So we're just plugging in there once we get it for that, right? So a lot of little details. You've got to pay attention. What all do I need? What do I know? What to plug in for those, right? And then part C, it says, at what time will we get to 39%? So how long will it take us? So we're looking for time. So that means our ending amount is 39%. So 63 or 66.5 e to negative 0.0079 t. So we divide 39 over 66.5 equals e to the negative 0.0079 t. We take the ln on both sides. And that's going to give me negative 0.79 t. So now we can divide. So you're seeing this process just over and over again. Let me start that 66 over that. Put my decimal in too early. Divided by negative 0.0079 will give us t. All right, now what you're going to see here is that t is going to equal 68. Okay, so it takes 68 years, but the question doesn't ask how many years. The question asks in what year. Okay, so we got to pay attention. Always the details when it comes to these word problems. So that means that we need to do 1960 plus 68, and we're going to get the year 2028. That's what year we're going to actually be in for that problem. Okay, so again, read your details. What are they looking for, so that you know how to handle those pieces. Okay. All right, so let's move on to the next problem. All right, this is probably by far the hardest problem. So let's look at it, take a little time here with it. I'm going to need to erase the board, so give me just a moment. All right, so this says we have a supply function and a demand function. So we're talking about business on those things. So supply and demand for that. And it says the sale of a certain DVD player is given by S of P. So supply or sell there equals 130 e to the 0.005 p. And then demand, D of P, is 455 e to the negative 0.002 p. Okay, so again, S is the selling price, D is the demand price for those. So it wants to find P such that the sell and demand, or the supply and the demand are equal. So D of P equals S of P. And so we want to use that piece there. Okay, and it's called the equilibrium price. All right, so again, just so we know what we're looking for, they want to know when is D of P equal to S of P. Okay, so when is D of P, the demand, equal to the supply? So we know what D of P is. That's 455 e to the negative 0.002 p. And we know S of P is 130 e to the 0.005 p. Okay. So now we need to start manipulating this equation to get down to what we need. All right. Now this time, because there are two e values, we can't just simply do the divide and things like that. Okay, so we got to actually break this thing apart and work through it. Okay, so what we're going to do here is we're going to go ahead and take the ln on both sides. Forgot to put my ln in front of that. Sorry there. Okay. Now, what we need to do here is remember some of our rules for logarithms. And so if we look at our expansion rules for logarithms, one of them says that if I have taken the log and have multiplication, I can turn that into addition. So I'm going to do that. So here I have multiplication. So I'm going to turn this into ln of 455 plus ln of e to the negative 0.002 p. All right, so I took this multiplication, broke it into addition. I'm going to do the same thing here. So ln of 130 plus ln of e to the 0.005 p. Okay. Now, why did I do that? So now, because I've broken this up, I have ln and e. So those things cancel each other out, leaving me with ln of 455 minus 0.002 p. Now, the reason why it's minus is because of the negative here. Positive and negative make a negative for that. So there's no e anymore, and ln for that part. We have ln of 130 plus 0.005 p. That's close my parentheses. Right? So by doing that little split, I was able to get rid of the ln and e on those specific pieces. Well, now we have our variables down where we can combine them. So I want to move this over with this one. So I'm going to go that way with that. And that means I also want to move this one over with this one. Okay, for those. So I'm going to have on this side ln of 455 minus ln of 130 equals, I'm going to add 0.002 to 0.005 and get 0.007 p, because I added the 0.2 to the 0.5. Okay. Now we're going to keep it simple at this point. We're just simply, and I'm going to move this up because it's pretty low there. I'm going to divide both sides by 0.7. So I have ln of 455 minus ln of 130, all divided by 0.007 equals p. Okay. Now, when you go to put this in your calculator, be careful. You need to put this whole top in an extra parentheses there for that. But at this point, because p is by itself, we can put this in our calculator and work through this. Okay. So when you put all that in your calculator, we find that the best price for supply and demand to be equal is $178.97. So 178.97 is what we're looking for as an equilibrium price on this DVD player, so that our supply meets our demand, but it isn't over on either side. Okay. All right, so as you can see, a lot of little tricks we had to use there from our sections. So we want to pay attention to those. All right, we've got one more problem. We're actually going to finish up with what I believe is an easy problem. So let's go down and look at it. The hardest part on this one, most people miss it because they're not paying attention where things go. And so just a second, let me erase this and then we will go over that. All right, so it says here, we have this child being born, and a parent is trying to figure out how much money they need to put in the bank so that when the child gets ready to go to college, they have $40,000 in the bank. So they're looking at what my end amount is. My end amount is $40,000, okay? And they want to know, what do I need to put in? So we're looking for P sub 0. The child will be 18 at this point, and it's compounded at 6%, okay? So when we look at that, just to kind of map those things out, we actually know what P of T is. That is going to be 40,000. We don't know P sub 0, so we're looking for that. We know K. K is 6%, so that's 0.06, and our time is 18. So we have all of those pieces. So we plug that in. So all of that tells me I have 40,000 equals P sub 0 e to the 0.006 times 18. Okay. Well, because what we're looking for is just being multiplied by something, we just need to divide. It's 40,000 divided by e to the 0.06 times 18 equals P sub 0. So we can put that in our calculator, and we should get that they need to deposit $13,583.82 for that one. Okay, so not a hard problem if we put things where it goes. Now, most of the times I see the mistakes is we see the 40,000, we think that's what goes in P sub 0, and we put it in the wrong spot. So read your instructions. What are we looking for? What do we know? So that we put them in the correct areas, okay? All right, so those should help you get through your problems. I covered the majority of your homework problems there. So make sure that you're looking at these. There will be some of these on the test. So make sure you know that process and how to identify what you need in each piece.